can you give me a step-by-step of the processing process, please?
All right, so once we collect blood from a blood drive, we'll bring it back to our campus over in Landstuhl. We'll take the temperatures, making sure that it's within range. Typically for transporting blood products, at least red blood cells, it's between 1 and 10 degrees Celsius. So we check that. Once that's good, we'll spin it down in a centrifuge, and that it's pretty much it's meant to separate your red blood cells from your plasma. And we'll pretty much squeeze it in a device that will just separate it, and we'll get the plasma to go to another tubing, another bag, and then from there, once we have it separated, we can weld it shut, weigh it, and then we'll put it in the fridge based off of what we need and what blood type that individual donor has. So we have to separate it out because if we keep it whole, the whole blood's only good for a certain amount of time. If we separate it out, we can put this preservative in there, and we're able to extend the shelf life on it for about 42 days is the most common. But that preservative that we put in there affects the plasma, so we have to separate it out. And then plus, it's good to have plasma by itself for any time of need. So like say if you're using whole blood, that's just a sheer volume. Like if someone's like bleeding out heavily, it's best to give them whole blood. If someone just has like a low hemoglobin, then you can give them red blood cells. If someone is also bleeding out, they need a clot, you can think fresh frozen plasma or platelets or even liquid plasma, just to kind of stop that. Normally you have like a low hematocrit when you're giving that out. So we all have our regulatory agencies. We have FDA, CAP, AABB, and they've come up with multiple testing errors, and they are the one who dictate this is the best temperature for such and such products, so we're just going along in accordance with those accrediting agencies. We have this cool device that it squeezes your whole blood. It has it separated up to where it has your plasma on top and your red blood cells on bottom. It's a device that just squeezes it, and as it squeezes, of course, the less denser thing on top, it's the plasma is what it is, and it's going through tubing and into another bag. And then once we have that plasma out, we're able to put that preservative, it's called Optisol, into the red blood cell, and we just use sheer gravity on that portion. So squeeze it to get it out, gravity put it back in. So with the plasma that we can't use here, we'll send it off to another laboratory. They use that to manufacture different products such as cosmetics. And we do get return for that money. It goes to buying incentives for donors like t-shirts or pint glasses. You know the saying, a pint for a pint whenever you get that done. But those bad plasmas are normally, whether it's a hemolyzed or lipemic, like if you come to donate blood after eating like a lot of like Burger King or something extra greasy, if you ever try to like walk upstairs after eating like KFC or something, you feel like, oh, I can't do this because your blood is really viscous. And we see that in the plasma actually, so we can say, oh, this person had like such and such food, and unfortunately we can't use it as a plasma because it's not healthy to give that to someone who's in need, but we still are able to save it and send it off to another lab to be used for other products such as cosmetics. So a good plasma is typically like a yellowish color to clear. You're able to like see your hand through it, almost like when you squeeze it, as long as you can like see your gloves through the plasma, you know, like, hey, this is pretty good. If it starts to get a little bit cloudy, that's no good, or if it's just thick, white, opaque color, then no, that's what we call lipemic. And it can also be hemolyzed, that's where it looks red. So hemolyzed comes from your red blood cells kind of bursting, and once that happens, then it's just no good for us. Okay, so for the job of the centrifuge, it's actually a refrigerated centrifuge, so it's keeping it cool, and it's just spinning it real fast, and that centrifugal force is actually separating the different elements of your blood. So it's separating the plasma from their RBCs, and then we're able to create what's called packed red blood cells. So again, it goes back to our guidelines. So if we're making FFP, fresh frozen plasma, those have to be kept around negative 18 degrees Celsius or higher. So those accrediting agencies are saying, hey, this product, to keep it stable, has to be at this temperature. So we're putting it in that fridge or freezer based off of what product it is, and we got to keep it stable until we get those test results back. Once we get those results back, we can then label those products and put it on our shelves and ship it out to whoever needs them. Our blood testing gets done by the American Red Cross and another stateside laboratory called Qualtex. So we're responsible for shipping blood to CENTCOM, AFRICOM, as well as good old Europe. Yeah, absolutely. Wherever it needs to go, we have people. We ship literally everywhere. I can show you like a board of like all the places we ship, but it's typically I think 12 bases that we routinely ship to, whether it be a forward operation base or like an actual base like Sigonella or Turkey. So it's any number. So the most important thing to me is actually knowing what it comes down to, like knowing who gets it, knowing that it is for a good cause. Like when I first started it, I was like, oh, I'm just going to be a phlebotomist. I'm just going to be drawing people's blood all the time. But it's very important. And actually our facility is, it's kind of morbid, but our facility is actually behind the morgue. So I've only been here 6 months and I've already seen a couple of caskets. So I know that it is used for a good cause. And wherever we can help people, I'm there to help them. So like the red blood cells typically weigh around like 380 to 400, and plasma is like maybe around 280 to 300, and it's just based off of how can I explain it? Certain weights are good and certain weights are bad. So if it's too low or too high, then we might have a bad product. It might be too concentrated or too diluted. So that's why we're using the weight to verify that.
Is that grams or kilograms?
Grams.